All right, chemists, this is going to be one of your longer lectures, so I hope you have, like, a nice glass of water, maybe some cookies, because we're going to be talking about chemical bonds. Now, when you think about chemistry, this might be one of the fundamental things you think about. But we have to understand what actually is a chemical bond. Well, it's a strong force. I don't want to say strong force. A powerful force of attraction between two or more atoms or ions. Now, we talked about what makes an atom stick together. We have a positively charged nucleus, negatively charged electrons. The nucleus is attracted to the electrons, so you form this sort of cohesive unit of an atom. But what if, if atoms on their own are interesting, but not as interesting as what happens when they start sticking together and making bigger substances? So there are many different ways that atoms that they can be attracted. So there are different kinds of bonding. Now, the thing is, though, they are all based on this one principle of electrostatics. So the same thing that keeps an atom together, the positive nucleus being attracted to the negative electrons, is also what causes atoms to stick together. The positive nucleus of one atom is attracted to the electrons of another, or the positive ion is attracted to the negative ion. So let's start looking at the different types. So you guys today in class saw these 4 models of bonding, and we went through the plays, or if we didn't go through the plays today, we'll go through them tomorrow. We have metallic bonding. So in this case, I should probably actually write that in blue. The blue represents valence electrons. Now, I told you long ago that valence electrons are super important to understand bonding. Well, here's why. Metallic bonding, we have the valence electrons in a C attracted to each of the individual nuclei of the atoms. Network covalent, we have electrons shared between 2 nuclei. Molecular covalent, we have electrons shared between individual atoms. And notice that no shared electrons between the different molecules. That might be a new word for us. Here, we just have, because this is one molecule, and we're going to talk about formula or the different ways to categorize this. And then in ionic, we have individual ions. So this is going to be negative. This is going to be positive. This is going to be negative. This is going to be positive, and so on and so on. And that's why they stick together. So let's look at each of the individual types. Now, take what we know about metal atoms. Metal atoms have a weak hold on valence electrons. Remember that term electronegativity? That's 17-letter word that just means how strongly they hold on to their outside electrons. Well, metallic bonding, large groups of metal atoms join together and share valence electrons in a common pool. See, they have this pool of electrons between them. This is why metals can conduct electricity, because the valence electrons aren't attached to any one single atom. They're shared throughout all of them. So if I apply a charge, I can push those electrons through, and that means it can conduct electricity. This is also why metals tend to be shiny. This is also why metals are bendable, tend to be ductile. If you are a history person, you can think about this as the communist model. Because in an ideal communist society, all goods are shared, all wealth is distributed and shared equally amongst all of the people, which has never actually quite happened. But in theory, that's what communism is. And in metals, all the electrons are shared equally between the atoms. All the valence electrons are shared equally between the metal atoms. If you need further, if you're a really deep history buff, you can think of communist Russia, the Soviet Union. Their sign was a hammer and sickle. Well, hammer and sickle made out of metals. So metals are the communist model. Communist means electrons are shared completely equally. But that's getting really deep into things. So here's what it looks like. So we have a fixed means not moving, cation. So that's a positive charge, right? The metal is giving up its valence electrons. And there is this fixed cation is really just an atom with its core electrons, because it's given up its valence electrons to the group. So each of these positive charges is attracted to the sea of electrons. So what that means is, as those electrons are in the middle, all of those fixed cations, all those metal atoms, are stuck together because they're all attracted to that sea of electrons. Remember, it's all electrostatics, pluses being attractive to negatives. So here, all of the metal atoms are attracted to that sea of electrons, right? So you can even go a little further. If we go down to this next row, you can see that they're sort of locked in place. While the electrons can move, there's still this sea of electrons. There's lots of electrons around for all of them to be attracted to. And that's why metals stick together. All right, so maybe this is when you'd want to take a break. You're probably going to be moving on to the next page of notes soon. If you do, remember, just turn the page, write in, the page number with an A next to it, or -1, or whatever you want to do to note that it's still the same page. If for some reason you're doing this after the fact and you've already moved on, well, you can rip a page out of the back and just staple it on. So you make sure that all of this stays together. Okay, combining atoms. So now we have metals and nonmetals. Well, we know metals have a low electronegativity. They're very weak. Nonmetals have a high electronegativity. They're strong. They really want those electrons. So this is what we've been talking about with ionic bonding, is that nonmetal atoms steal valence electrons from metal atoms. This is the first step in the process. Then, as that happens, the non-metals become negative ions, called anions. The metals become positive ions, which are cations. Remember, cat's positive. And then these ions assemble into a matrix of alternating charges. So it goes plus minus, plus minus, plus minus in 3 dimensions, and which I'll show on the next page. So you can think about this in terms of like a dictatorship, where the strong steals everything from the weak. So the nonmetals grab electrons, they get those negative particles from the metals, and they become negative. The metals lose their negativity, so they're giving up some negatives, so they become positive, and that causes them to stick together. All right, and then here are just a couple of drawings of sodium chloride. So you can see that in the first model, you have alternating plus and minus ions, and they're all stuck together. That positive and negative charge is very, very, the attraction between the positive and negative charge is very strong. So they stick together very tightly in this matrix. Now, if you look down here, this is what we call space filling, or really the 3D model. So this pattern you see of alternating charges goes on, you know, in all directions. So now let's combine nonmetals only. Now these are strong. Nonmetals are strong. Right? They have a high electronegativity. They pull very tightly. So this is called covalent bonding. And if we use our SAT skills, you know, it's another year or so away, but it's good to practice. Co means together, like cooperative. Valent means the valence. So you can think of this as co-ownership of valence electrons. And how this works is that two non-metal atoms share their valence electrons. Now, covalently bonded atoms. We're going to talk a lot more about covalently bonded atoms in the next unit. Covalently bonded atoms can form small groups called molecules. We're going to look at this further in the next lesson. This is common that they do. This is how they most commonly form. Or they can make large networks. And this is rare. So let's move on. So here's a model covalent bond. Hydrogen, H2. You have the two positive nuclei. So let's come on, hydrogen. There's a plus. Plus. Remember, the nucleus of all atoms are positive. So the hydrogen nucleus, each hydrogen nucleus is attracted to the shared electrons, and neither wants to let go. So it's like they're both pulling on the valence electrons, like two dogs pulling on a rope at the same time. Neither one wants to let go, so they're stuck together. So here's the positively charged nuclei, like I was explaining, the shared electron cloud. So this hydrogen says, I'm not going to let go of these electrons. This says, neither am I. Then I guess we're stuck together. Oh, I mixed the voices up. Don't worry about it. Works for me. Okay, so they stick together because both of the nuclei are attracted to the shared electrons. All right, so a little bit more. We're getting there. Ionic bonding is an attraction caused by the transfer of electrons from one atom to another. Then there's covalent bonding, an attraction, where a pair or pairs of valence electrons are shared between two atoms. Now, this can be what we call molecular covalent, where they make those small discrete molecules, or they can be called network covalent, where they make those big, huge matrices where they're all stuck together. And for network covalent, really, the only ones we think about normally are diamond and graphite and silicon. All right, metallic bonding. An attraction in which a group of metal atoms pool their valence electrons. And here, the valence electrons are free to flow. And then this term molecule, I don't like vocab. I'd much rather have you guys show understanding than actually do vocab. But this is an important word. And for a molecule, it's a group of atoms covalently bonded together. So you cannot say a molecule of salt, because salt is not covalently bonded together, right? Salt is ionically bonded together. We say molecule only for things that are covalently bonded. Okay, so now this chart that we made in the previous lesson, we can label it. We can go back and label in yesterday's notes the 4 different types of bonding based on how we can classify the substances. So what I want you to do is you can pause the video here, go back to yesterday's notes, and fill in that if it dissolves in water and conducts electricity, it's ionic. If it dissolves in water and does not conduct electricity, it's molecular covalent. Does not dissolve, does not conduct, network covalent. Does not dissolve, does conduct, is metallic. So go back and fill this in from yesterday. Okay, we're back. So now, the last little bit for today, and then we wrap up. So bonding relates the type of atom in a substance. So if I tell you that a substance conducts electricity when it's solid, well, you know it's metallic bonding, so you must have metal atoms. If I know a substance, I'm moving over all the way to the right, if a substance dissolves in water, and when it does, it conducts electricity, it's ionic, so then therefore it must be made of metal and nonmetal atoms. So if I gave you the properties of a substance, you should be able to tell me the types of atoms that are that compose that substance. Not necessarily the identity, right? If I say, oh, a substance dissolves in water and conducts electricity, you can't tell me that it's sodium chloride. All you know is that it's composed of metal and nonmetal ions. All right, finishing up. The question was, how are atoms connected to one another? So a chemical bond is just an attraction between atoms involving valence electrons. Remember, it's all electrostatics, pluses being attractive to negatives. There are 4 types of bonding: ionic, network covalent, molecular covalent, and metallic. And that the valence electrons are just distributed differently depending on the type of bonding. Okay, thanks for listening. These are really key ideas to understanding chemistry in this lesson.